Hello students, welcome back to the quick solution discussion of AIATS for JEE Advanced 2020. After the discussion of paper 1, now we are going to discuss test 1A paper 2 and the code is code G and code H. Okay, so let us begin the solution discussion with question number 37. Question number 37 says that let P is equal to sin pi by 7, sin 2 pi by 7, sin 3 pi by 7 and Q is equal to cos pi by 7, cos 2 pi by 7, cos 3 pi by 7. Then I have to find the value of P, Q, P into Q or P by Q. So students, how are we going to deal with this particular problem based on trigonometry? Let us start from Q first of all. Q is cos pi by 7, cos 2 pi by 7, and if I carefully observe, this is pi minus 4 pi by 7. So this is minus cos 4 pi by 7. So cos of 3 pi by 7 can be written as cos of pi minus 4 pi by 7. This is minus cos 4 pi by 7. Why I have done so? Because I know the product of cosine terms in which the angle is getting doubled in each step. So let us multiply and divide by 2 sin pi by 7. So 2 sin pi by 7, cos pi by 7, cos 2 pi by 7, cos 4 pi by 7 with a negative sign divided by 2 sin pi by 7. We know that the first two terms will become sin 2 pi by 7. Then I'll again multiply and divide by 2. 2 sin 2 pi by 7 cos 2 pi by 7 will become sin 4 pi by 7. And again I'll multiply and divide by 2. Ultimately I will get minus sin double of 4 pi by 7. That is 8 pi by 7 divided by 2 raised to the power 3. That is 8 sin pi by 7. Now 8 pi by 7 is pi plus pi by 7. Sine of pi plus theta is minus sine theta. Minus minus sine cancels. This is 1 by 8 simply. Because sine pi by 7 upon sine pi by 7 gets cancelled. The value of Q comes out to be 1 by 8. That means option number B is wrong. Option number A is also wrong. Because students, we can clearly see that P can never be equal to Q. Okay. Now let us try to calculate P. Okay. So P is sine pi by 7. Sin 2 pi by 7, sin 3 pi by 7. Let me square it. So P square is sin square theta, that is 1 minus cos 2 theta, again 1 minus cos 2 theta, again 1 minus cos 2 theta. So 3 terms, which is further equal to 1 minus cos 2 pi by 7 into cos 4 pi by 7 is minus cos 3 pi by 7. This is 1 plus cos 3 pi by 7. Cos 6 pi by 7 is minus cos pi by 7. So 1 plus cos pi by 7. Now let us put pi by 7 as theta. So P square you will get 1 plus cos theta into 1 minus cos 2 theta into 1 plus cos 3 theta. So there are going to be 8 terms in the expansion. First term is 1. Then we will have cos theta minus cos 2 theta, cos 3 theta, minus cos theta cos 2 theta, minus cos 2 theta, cos 3 theta, plus cos theta, cos 3 theta, minus the product of 3 terms cos theta, cos 2 theta, cos 3 theta. Students, now by using the transformation formula in these 3 expressions, this expression, this expression, this expression, these 6 terms will come out to be 0. And we have done a little mistake above. Sin square theta is 1 minus cos 2 theta by 2. So divided by 2, divided by 2, divided by 2. So instead of P square, it will be 8P square on the left hand side. Okay. So 8P square ultimately comes out to be equal to 1 minus 1 by 8. That is 7 by 8. So that means the value of P is root 7 divided by 8. Q is 1 by 8. And P is root 7 by 8. What is the value of P into Q? Root 7 by 64. What is the value of P divided by Q? That is root 7. So final answer of the question rests as CD. Okay, let us move on to next question. Question number 38. Consider the identities cos 4 theta equal to 2 cos square 2 theta minus 1. Pretty normal. Cos 3 theta 4 cos cube theta minus 3 cos theta. Again, we know the formula. Cos 2 theta we know the formula. Sin 4 theta we know the formula. Sin 3 theta we know the formula. The expansion of E1, that is what we don't know. But students, there is a very clear hint that you can see that sin 2 theta cos 2 theta, the formulas are in square terms. Sin 3 theta cos 3 theta, the formulas are in cube terms. And if you expand sin 4 theta, the formulas will be power 4 terms. So power 7, how we will get power 7? By expanding cos 7 theta. Okay, so that means I have cos 7 theta as cos 3 theta plus 4 theta is equal to cos 3 theta cos 4 theta minus sin 3 theta sin 4 theta. How we will expand these terms in order to get cos everywhere? This is directly known. 4 cos cube theta minus 3 cos theta. Cos 4 theta is also directly known. How? This is 2 cos square 2 theta minus 1, and cos 2 theta is further 2 cos square theta minus 1 whole square. Cos 4 theta, how we will expand it? 2 cos square 2 theta minus 1, and cos 2 theta is further equal to 2 cos square theta minus 1. So 2 cos square 2 theta minus 1. What about sin 3 theta and sin 4 theta? Sin 3 theta is sin theta into 3 minus 4 sin square theta. So sin square theta can be directly converted into cos square theta. Sin 4 theta, 2 sin 2 theta cos 2 theta. 2 sin 2 theta cos 2 theta. Now sin 2 theta will be further written as 2 sin theta cos theta. This sin theta and this sin theta will combine. Ultimately, I am going to get cos 7 theta as 64 cos power 7 theta minus 112 cos power 5 theta plus 56 cos cube theta minus 7 cos theta. This is the expansion of cos 7 theta. Okay. Now E1, if you watch carefully, this term is here, this term is here, this term is here, this term is here. Two terms are not there. Minus 2 cos square theta plus 1. So if I put E1 equal to 0, I will get cos 7 theta minus 2 cos square theta plus 1 equals 0, which means that cos 7 theta is equal to cos 2 theta. General solution of cos x equal to cos alpha, x equal to 2n pi plus minus alpha. So taking the positive sign, I have 5 theta equal to 2n pi. First possibility, taking the negative sign, I have 9 theta equal to 2 m pi, where m and n are integers. Solving them, I have theta equal to 2n pi by 5 or theta equal to 2m pi by 9. The same condition holds, m and n are integers. Now students, let us go through the options very carefully. Okay, least positive value of theta satisfying the equation E1 equal to 0 is 2 pi by 5. So let us write some of the solutions. It can be 0, it can be 2 pi by 5, it can be 4 pi by 5 on the positive side, or here it can be 0, 2 pi by 9. So what is the smallest positive value that we get? The smallest positive value that we get is 2 pi by 9 and not 2 pi by 5. Option number A goes wrong. Number of values of theta lying in the interval 0 to pi by 2. 0 to pi by 2. This value 2 pi by 9 lies in 0 to pi by 2. 2 pi by 5 lies in 0 to pi by 2. And we have an open interval. 4 pi by 9 also lies in 0 to pi by 2. 6 pi by 9 is out of 0 to pi by 2. So 3 values correct. Option B is absolutely true. Number of values of theta lying in 0 to pi. So let us further write the solutions. 6 pi by 5, obvious, greater than pi. Here 6 pi by 9 and 8 pi by 9. So from here, how many values do we have? 1, 2, 3, 4, 5, 6. 6 values lying in the interval 0 to pi. Open. Final answer option number B and option number C. Okay, let us move on to next question. Okay students, so let us talk about question number 39. It says that consider the two functions fx is equal to log of cos square x to the base sin x and gx is equal to signum of tan x. Then option number A and option number C are talking about fx equal to gx. Option number B and option number D are talking about fx equal to 1 and fx equal to minus 1. So I'll have to solve by options. First of all, let us solve B option. F of x equals 1. This is the condition of B option. Fx equal to 1 means cos square x is equal to sin x. That means sin square x plus sin x minus 1 equals 0. That means sin x is equal to minus 1 plus minus under root of 5 divided by 2. Careful students, sin is in the base of log. It cannot be negative. Sin x is equal to root 5 minus 1 by 2. How many solutions in 0 to 2 pi for a positive value lying between 0 to 1? 2 solutions. Option number B is correct. For option number D, fx is equal to minus 1. Cos square x is equal to sin x raised to power minus 1. Cosecant x. Never possible. Why not possible? Because cos square x is a quantity lying between 0 to 1. The only point common with the range of cosecant x is 1, then cos x has to be 0. Okay? Not possible simultaneously. They can never be equal. Not possible means no solution. Option number D goes wrong. Now students, fx is equal to gx. 3 possibilities are there. Gx is signum of tan x. Signum of tan x can take only 3 values, minus 1, 0, 1. We don't have any solution for minus 1. So third case is closed. Let us check for fx equal to 0. If fx is equal to 0, that means first of all, gx has to be 0 because I am solving via fx is equal to gx. Gx is 0, that means tan x is 0. So there are two conditions which are to be simultaneously satisfied. Tan x is 0, fx is 0. If fx is 0, there is only one possibility, cos square x equal to 1. But students, if tan x is 0, sin x has to be 0. And sin x is present in the base of logarithm, can never be 0. So no solution from there. Again, minus 1 was already ruled out. 0 is also ruled out. Fx equal to gx. Third possibility, fx is equal to 1 when signum of tan x is 1. That means tan x has to be positive. Over here, there is an extra condition that tan x is positive. Okay. If tan x is positive and sin x is equal to root 5 minus 1 by 2, sin x is also positive, I have only one solution. For which option I am talking about? I am talking about fx equal to gx. That means option number A or option number C. One solution from fx is equal to 1. No solutions from minus 1. No solutions from 0. Answer is exactly one solution. Option number A is correct. C has to be wrong. Final answer AB. Okay. Let us move forward to next question. Talking about question number 40 based on complex number, it says that complex number z1 and z2 satisfies the equation z upon z bar plus z bar upon z is equal to 2z and real part of z plus z minus z bar minus 1 upon z minus z bar is equal to 2 iota respectively. This is the condition of z1 which says z square plus z bar square upon z bar equal to 2z. That means z square is x square minus y square plus 2 iota xy. Z bar square is x square minus y square minus 2 iota xy. So 2x square minus 2y square divided by x square plus y square. That means it is purely real. This is 2x plus 2iy because z is x plus iy. Y has to be 0. Left hand side is purely real. Right hand side has imaginary part 2y. Y has to be 0. If y is 0, we get 2x square upon x square, that is 2 is equal to 2x, so x is equal to 1, which means that z1 is 1 plus 0 iota. Very simple complex number given under a tedious condition. Solving for second complex number, we have real part of z, x, z minus z bar, 2 iota y, minus 1 upon z minus z bar, 1 upon 2 iota y is equal to 2 iota. Right hand side is purely imaginary, left hand side has real part x, that has to be 0. Simply we get 2y plus 1 by 2y is equal to 2. How? Minus 1 by iota is simply iota. So I have compared the imaginary part on both the sides. Y, so this will give me 4y square minus 2y plus 1 equals 0. That is 2y minus 1 whole square, which gives me y equal to 1 by 2 exact. X equal to 0, y equal to 1 by 2. That means Z2 is 0 plus iota by 2. Very simple. Number of possible complex number Z1 is 1, correct. Number of possible complex number Z1, 0, wrong. Number of possible complex number Z2 is 1. D is correct. Final answer for this question, AD. A very simple problem. Let us move on to 41. Question number 41 says that one of the roots of the quadratic equation x square plus bx plus c equals 0, where b and c belongs to real, is 1 plus iota. Coefficients are real, one root is complex, other root has to be its complex conjugate, that is 1 minus iota. Consider another quadratic equation Q, px square plus qx plus r equals 0, where p, q, r are distinct and belong to the set 1, b, c. So first of all, we have to find out b and c using two roots. Number of quadratic equation q equal to 0, q equal to 0, all the possibilities are being asked after putting the values of p, q, r where they are given to be distinct. So first of all, let us evaluate b and c. One root is 1 plus iota, other root is 1 minus iota. What is sum of roots? 2. X square minus sum of root times x. What is product of roots? 2. Plus product of roots equals 0. We get b as minus 2 and c as 2. So now p, q, r belong to the set 1 minus 2, 2, whereas they cannot be equal to each other. So we have total 6 possibilities, 3 possibilities for p, corresponding 2 possibilities for q, corresponding last possibility for r. Q equal to 0 can be any of these 6 equations. First equation, x square minus 2x plus 2 equal to 0. First possibility. Second possibility, x square plus 2x minus 2 equal to 0. Third possibility, 2x square plus x minus 2 equal to 0. Fourth possibility, 2x square minus 2x plus 1 equal to 0. Fifth possibility, minus 2x square plus 2x plus 1 equal to 0. Last possibility is minus 2x square plus x plus 2 equal to 0. We have to comment on the roots, nature of roots. Discriminant 4 minus 8, negative. Discriminant equal to 4 plus 8, that is 12. Discriminant equal to 1 plus 16, 17. Discriminant is negative, 4 minus 8. Discriminant is 4 plus 8, 12, and discriminant is over here equal to 1 plus 16, that is 17. Now students, listen. Imaginary roots, imaginary roots. If D is a perfect square and B, C, A are rational, the roots are rational. If D is not a perfect square, the roots are irrational. So over here, irrational roots, irrational roots, irrational roots, irrational roots. 4 cases of irrational roots, 4 cases of real roots, 2 cases of imaginary roots. Option number A, wrong. Option number B, correct. Option number C, correct. Option number D, wrong. Final answer, rest as BC. Let us move forward to question number 42, the last question of this section. Question number 42, based on graph transformations, says that consider two functions fx is equal to modulus of x square minus 2x minus 1 and gx is equal to modulus of 2 sine pi x upon 2. The graph of gx, that is mod of 2 sine pi x by 2, the normal graph of sine x covers one cycle in 2 pi. So this will cover in 2 pi upon pi by 2, that is 4 units. So let us draw the graph. Okay, so we have the coordinate axis with us. First of all, we'll draw the graph of 2 sine pi x by 2. This will be the graph. The corresponding values will be 0, 2, 4 on the right hand side, minus 4 and minus 2 on the left hand side. So minus 4, minus 2, 0, 2, 4. After that, what are we going to have? We are going to apply the mod of this particular function. While applying mod, this negative part and this negative part will go upward and they will give positive values as well. So this will be the graph of mod of 2 sine pi x upon 2. This red graph signifies the graph of the function gx. Now let us talk about fx. X square minus 2x minus 1. So it is a shifted form of x minus 1 whole square. That is a shifted form of x square. So drawing this particular graph by using transformation of graphs, very simple one. We have this graph. So the maximum value is 2. This point is exactly 3, 2. You can check it over here. This point is minus 1, 2. You can check it over here. So carefully you have to draw the graph. You also have to check the values of f0. For x square minus 2x minus 1, it is negative. F of 2, it is again negative. So it is very symmetric graph with respect to the line x equals 1. Okay. Now we have to take the mod again. So negative part will go up and it will be positive. So this green graph is the graph of y equal to fx. Okay. The number of solutions of fx equal to gx is 7. Here are the number of solutions. 1, 2, 3, 4, 5. Wrong. Number of solutions of fx equals a if a is belonging to 0, 2. Obviously, students, this value is 2. I told you the maximum value of this particular function and the value at x equal to 1 over here is 2. So now what is the scenario? Number of solutions of fx is equal to a is 4. So if we draw a line parallel to x-axis lying between 0 to 2, 1, 2, 3 and 4 points of intersection with the green graph, it is a correct option. Number of solutions of fx is equal to a is 3 if a is equal to 2. Yes, the dotted line meets this graph at 3 points which are already marked over here, 1, 2 and 3. This is also correct. The set of exhaustive values of a for which fx is equal to a has exactly 2 solutions is 2 to infinity. Okay, so that means if I draw a line over here, I can see that I am getting 2 solutions everywhere. But if I draw a line which is the x-axis, over here I am also getting 2 solutions. 2 to infinity is correct, but union 0. So it is saying the exhaustive values. So it doesn't form the exhaustive values of a. Exhaustive means completely equal to that thing. Option number D is wrong. Final answer is BC. Now let us move on to next section that contains integer type problems.